degrees and radians are just different ways of measuring angles. And in this video, I'm going to tell you a little bit about what radians are and where they come from. And then later in the video, we'll look at how to convert between the two different types of measurements. So what we got in our picture here is a circle, of course, and some measurements of angles relative to this positive horizontal axis, which I've defined to be 0 degrees. So you can see moving around the circle, we've got 90 degrees up here vertically, obviously a right angle, 180 over here to the left, 270, and then 360 when we come back around for a full rotation. I've also marked in a couple of other angles in there, 30 degrees, which would be this angle in here, 45, 60, but also one other which is a bit unusual and which I don't exactly know what the value of is, which I've clearly marked out. It's the angle that's formed here by a radius and then an arc on the circle which has the same length as the radius. So I've pointed that one out in particular because that's exactly how we define a radian. So a radian is the angle formed by two radii, this one here and this one up here, and an arc which is the same length as the radius. So you can see the angle indicated right inside here. So that angle is exactly 1 radian. I'm not sure how many degrees that is though, but we'll deal with that later. Because a circle's circumference has a length given by the formula c equals 2 times pi times r, we can say that there are exactly 2 pi radius lengths in a full circle. So in other words, in a full rotation around the circle, we'd have 2 pi multiplied by the length of the radius, or 2 pi radius lengths around there. So in other words, this leads us to a statement of equivalence because we know that going all the way around the circle is 360 degrees. If we also know that it's 2 pi radius lengths, that means we'll also form 2 pi lots of these radians, or that little angle inside there. So we can say that 360 degrees is going to be equal to 2 pi radians. It's an equivalent statement. Same angle, 360 degrees is 2 pi radians. Now, why is that useful? Well, that's useful because it allows us to convert between the different types of measurements. Just to finish up my circles up here, though, I can now say that I've got 0 radians. I'm going to shorten it to rad. I could also say that's 2 pi rad, or radians, if I was to go all the way around the circle. Now, if I only went halfway, it wouldn't be 2 pi radians, it'd be just 1 pi radian. So I've only gone half of a full rotation. So I might pop in there pi radians. So you can see a few more equivalences will start to pop up. Pi radians is the same as 180 degrees. Now, if I only went a quarter of the way around the circle, that'd be 1/4 of 2 pi, or pi on 2 radians. So we can start to fill in more of these things. Pi on 2, pi, 3 pi on 2 down the bottom here. And if you like, you could start to figure out some similar equivalences for our other angles like 30, 45, and 60, or anything else that pops up a lot in the work that you're doing. So I was saying that our conversion would be possible by using that equivalence statement. Remember, the equivalence statement was that 360 degrees is equal to 2 pi radians. So we can use that to get a conversion between degrees and radians. We can also think of this as being a sort of proportional relationship. So if we know something has an angle of x in degrees, we can say that that's equal to x degrees divided by 360 degrees. So in other words, how much of a full rotation is it? And then multiply that by how much a full rotation is in terms of radians. So the original angle we've got divided by 360 degrees multiplied by 2 pi radians. So those will be equivalent angles. Reversing that, thinking of it in the other way, we can say that if we know we have an angle of x radians, let's say x rad, we divide that by 2 pi rad, 2 pi radians, That tells us how much of a full rotation we've got. And then we want to multiply that by what a full rotation is in degrees. So let's check out a couple of examples of how this works. I want to convert 270 degrees to radians. So this is where we're up here. We could use that formula if you like, or we can think about it conceptually. We've got 270 degrees. How much of a full rotation that is that? We divide by a full rotation in degrees, and then multiplied by 2 pi radians. 270 degrees divided by 360 degrees is 3/4. So 3/4 multiplied by 2 pi radians. It's going to be equal to 3 times 2 is 6, divided by 4 is 3 on 2 pi radians. Or if you like, 1.5 pi radians. Another example, let's go back the other way. If I want to convert 2 pi on 3 radians to degrees, again, I'll start by dividing 2 pi on 3 by a full rotation, which is 2 pi radians. You know, I want to multiply that by what a full rotation is in terms of degrees. So we have 2 pi on 3 divided by 2 pi radians. So that's going to be 2 pi on 3 times 1 on 2 pi, or just 1 on 3, multiplied by 360 degrees. And that, of course, is going to be 120 degrees. So there we go. Converting angles from degrees to radians and radians to degrees. We've got some conversion relationships that we can use if we like, or you can think about it conceptually as how much of a full rotation we have, and then converting that by multiplying by the corresponding amount of a full rotation in the angle measurement you're looking for. Oops.